Accurate 3D modeling is required for very complex systems found in recent designs to allow for structural optimization and high-speed signal compliance. In particular, high-speed signals such as 112G SerDes interface must have a solid interconnected design. However, conventional field solvers have limitations in analysis speed and capacity, and the engineers have to simplify the structure or divide the layout into several segments to run within the constraints of the machine environment. In such a pseudo 3D method, the analysis result is varied by model reduction skill. This will be a risk factor in terms of analysis accuracy. Clarity 3D Solver is a full 3D field solver equipped with the cutting-edge parallel processing technology. Clarity enables distributed computing using cloud or on-premises machines for large-scale model analysis. So, you can do the very accurate analysis without degenerating models. Traditionally, there are two methods that have been taken in the distributed computing with finite element method. The first method is to submit a job from the host for each analysis frequency. In this method, the memory used by standalone environments and each machine during distributed computing will be the same. This increases the amount of simultaneously used memory, which leads to an increase in machine load. Another method is to divide one layout into several partial elements. In this method, you can reduce the required machine resources, but the interactions between the divided elements are not calculated. It may lead to a critical accuracy problem, since this also splits the ground path. Clarity 3D Solver is an innovative solution that overcomes the performance and accuracy problems in the distributed computing with cutting-edge technology. Clarity enables massively parallel computing with cloud or on-premises machines. You don't have to worry about the amount of memory, as distributed processes are performed as if multiple machines are on one. In addition, Clarity suppresses the performance decrease in performing distributed computing. It enables the almost linear scalability to a number of CPUs. On the other side, Clarity Solver does not divide the layout into several partial elements. Clarity Solver accumulates many measurement correlations. The result of adaptive mesh and frequency sweep are equivalent to those without distribution. In traditional distributed computing, the shape processing, the mesh generation, and the design partitioning are performed by a host machine. Then the host machine passes the mesh data to the remote machines, and remote machines return the result to the host machine. Clarity distributed computing is different. Clarity also distributes the shape and meshing process to the remote machine. You can always run with optimum performance because Clarity calculates optimum parallel jobs each time from a required number of cores. From the host machine, the remote machines, which are used by distributed computing, looks as if they were multi-core processes in one machine. The analysis size and speed are determined by the total amount of available memory and the number of cores on the remote machine. In addition, Clarity Solver does not limit on the number of parallel and the amount of memory, so you can handle any structure with this virtually unlimited memory environment. Clarity Engine also allows you to use the cloud environment as a remote machine. By using services such as Microsoft Azure and Amazon AWS, you can perform large-scale analysis easily. Let's look at an example of analysis correlation using Clarity Solver. The packages, PCBs, and connectors have to be strictly modeled in order to verify 112G SerDes interface. Therefore, we propose Clarity Solver to perform high-precision wideband modeling. In particular, you will need to extract the connectors taking into account the complex 3D geometry and considering the interference with printed circuit board. Clarity also enables the extraction with the amazing performance for combined structure of connectors and PCBs. This is an actual measurement correlation result for Clarity Solver. The eye diagram is correlated very well, even in such a complex PAM4 transmission. This is evidence for correct interconnected modeling between TX and RX. This indicates that Clarity Solver gives you the accurate modeling for SI-PI analysis. As you can see, using the Clarity Solver in combination with the Sigrity enables an integrated environment for power-aware SI analysis. Let's look at a performance comparison example. Again, we're going to use the same test case for 112G SerDes interface. We set the analysis time using a conventional solver as 1. Even with the same environment, the Clarity performance is improved by about 1.6 times. Distributing 2 machines and doubling the number of cores, the performance is approximately tripled. Distributing 4 machines and quadrupling the number of cores, the performance is multiplied by 6 times. Distributing 8 machines and 8 times the number of cores, the performance is multiplied by 12 times. This is another test case. In this DDR4 interface verification example, the performance improvement in the same environment is 1.4 times. Distributing 2 machines and doubling the number of cores, the performance is 2.6 times. The performance is multiplied by about 5.2 times when processing is distributed to 4 machines and the number of cores is quadrupled. Distributing to 8 machines and the number of cores is increased by 10.4 times. From this, you can see that Clarity is improving the performance linearly with the number of CPUs. In this way, the Clarity Solver contributes to the reliability and short turnaround time of your SI-PI analysis in all aspects of performance, accuracy, and scalability. Today's high-speed design is getting more difficult each day. In particular, 3D solvers are essential for verification of ultra-high-speed interfaces, as introduced in the previous example. But in traditional solvers, there are often problems with analysis time and accuracy. In addition to the demand for higher data rate, there are various hurdles to be solved, such as increased system reliability, lower power requirements, and lower cost requirements. Clarity 3D Solver achieves accurate analysis with short turnaround time in complex and high-speed system designs, such as 112G communication network, IoT, automotive, ADAS, and more. Clarity helps to improve overall system performance and reduce design costs.